Hey guys, I hope that y'all did well in your quiz yesterday. Hope that you enjoyed the activity. A lot of the things that we talked about last in that activity in terms of z-scores and percentiles we're going to use today. I'm going to try not to bore you too much and make this too long. So I do expect for you to read some of these examples on your own, because some of these are going to be really helpful to you understanding why it is what's happening is happening. It'll make sense in a little bit, but I don't feel like I need to read them to you. So last class in that activity, we talked about what the word percentile and z-score meant. So we're going to talk about those today as well as a few other things. So y'all found some percentiles in terms of your height in compared to the class, the class's heights. So what we have here is we have an example about finding percentiles. And so y'all have done percentiles before. You've seen them anytime you took a standardized test at elementary school. They would tell you, you're in the 85th percentile for math, which means that you did better than 85% of the students that took that test. So if we want to calculate a percentile, we just need to find the number of people below that score or that value and then find the percentage. So, take the number that are below that value and divide it by the total that you have. So the first thing that I wanted to do, since I kind of need for things to be ordered, like this says, they want to find the percentile for Norman who scored a 72. So I need to know how many scores are below 72. So what I did is I took this data and I sorted it in L1. So if y'all want to pause the video, go ahead and put the data in your calculator. It's kind of already all done for you, so I don't really know if there's a need for you to pause, but I'll show you what I did. So I took this data, I put it in my calculator. I see that there is only one score here is 67 that's below Norman's score of 72. Now this, if you notice, if you look up here at the definition of percentile, it says less than the percent of observations less than P or whatever it is. So whatever your value is. This is strictly less than, which means it's not less than or equal to. So we're not going to include the 72. We're just going to do everything less than 72, which is only one thing. So the percentile is just going to be 1 over 25, which is 0.04 or 4%. So then they want to find the percentile for 93. So if I go into my list and I go, let's see where I can find 93. Oh, wow. So 93 is the highest score. So that means there are 24 scores that are lower than 93. So the percentile for Katie's 93 is going to be 24 divided by 25, which is, it says 96%. So she's in the 96th percentile. 80th percentile, that two students who scored 80. We want to find all the students who scored less than an 80. And there are 12 of those if you go back and look at your list. And you'll see that that's the 48th percentile, 12 divided by 25. So that's pretty simple. I mean, count the number of scores lower than that and you found percentile. So now let's talk about a few things. A graph that we can use to find percentiles, it's what's called an ogive. I think it's a really fun word to say. Not all books use this word, but I've used books who use it, and it's so fun. Ogive. Oh, I don't really know how to pronounce it phonetically, but I think it's cute. You get to say the word jive. Plus, it really looks like it'd be ogive, but it's not. It's ogive. And so we talked when we talked about histograms. We're going to kind of switch gears for just a second, but it'll all come back together. We talked when we talked about histograms about what's called relative frequency and how you can make a relative frequency histogram. And this, if you look right here, they've given us the ages for the first 44 U.S. presidents. They put it into a frequency table for us. And so if we wanted to calculate relative frequency like they've done right here, all we would do is take the frequency for each one of those classes and divide it by the total, since there are 44 presidents here. Always helpful to read the question when you want to find the total. Then you just take each one of those frequencies and divide by 44, and it gives you all your percents. Okay, so we have another type of frequency that I'm going to define for you. I haven't defined this yet, so let me give you a definition for it. It's called cumulative frequency. Let me erase a little of this so we can see. So I can write some vocab for you. I should have put this on your sheet, but I didn't. So this is going to be the sum of the given class. Let's say sum of the frequency of the given class. Ooh. And all the classes before it. Sometimes my green marker doesn't like to work. Woohoo! I think I'm going to use blue from now on. It's dancing! Okay, I'm done with the green. So this will kind of tell us, how can I explain this to you? Like if I'm in the class from 45 to 49, then there are 9 presidents that are 45 to 49 or younger. So it tells you that value plus everything that comes before it. And then what's really interesting to us in terms of percentiles is what's called cumulative relative frequency. And you're just going to put the two together. For relative frequency, you take the frequency and divide by the total. For cumulative relative frequency, you just take the cumulative frequency and you divide by the total. I think it's pretty self-explanatory. But what the cumulative relative frequency is it's a graph of all the percentiles. And it gives you an estimate. Now, it's not going to be perfect because it's, you're only using dots and then you're going to connect the dots, but it'll give you an idea. So what this tells us, if we look at this value right here, the 20.5%, is that 20.5% of all presidents are ages 49 and below. So if I asked you for the percentile for a president who was 50 years old, you look at everything less than that, you could tell me that that is 20.5%, because it would be the percent of all the presidents who are less than 50 years old. And that's what this cumulative relative frequency tells you. So here we have a graph of the cumulative relative frequency. This is an ogive. An ogive can either just be cumulative frequency or it can be cumulative relative frequency. It doesn't matter. So let's think of a couple things that we could do with this. What if we wanted to estimate the percentile for age 55? Then we would go over to 55. Let me see if I can make straight lines on my smartboard because I'm not so good at making lines. Then we go up here. We go to 55. Oh, I see it didn't work either. Let's try again. Nope, that didn't work either. That's pretty good. There we go. And we make a straight line till we hit the graph. And then now we're going to take this right here and we're going to go over there and we're going to see what the percentile is. So this over here on your y-axis for your cumulative relative frequency is just your percentiles. So they want to know the percentile. I can't talk. For age 55, I go to 55, I go up to my graph like this, see my line, and then I go over and I see it's approximately the 50th percentile. Now you can also read this backwards. You can also say, hey, what is the age for the 75th percentile? So I'm going to do this whole straight line thing again if I can get it to work. So I know that if this is 80 right here, then 75 might be, let's see, that's probably about 70. Let's call that, oh crap, that's not really 75. Let's try this again. Let's pretend that's 75. And then I'm going to take my little straight line maker. Oh, that didn't work. Crap, that didn't work either. That's good enough. And I'm going to go over here and hit the graph. And I'm going to come over and come down here. It might be helpful if you use a ruler when you're doing this. I'd say it's about 58, 59 years old. So you would say approximately 50, let's say 59 years old. It's just going to be an approximation. But that's how you're going to figure it out, is you're going to make lines like that on your ogive. So on the next page we have an example. And it's pretty much exactly what I've just done for you. So I don't really want to go through it. It shows you how to look. So if you need some more help, you can read through this. But I want to go down. Oops, I lost it. Oh crap, I hate it when it goes over there. We want to go down, and we want to work this example out. And y'all are going to do this on your own. You're not going to do part C, because I did it, and it took an insane amount of time, and I just don't want to mess with it. All right, so think about interquartile range. Now, the Q3 is where 75% of the data falls below that value. That sounds like something that we just heard, didn't it? So I think that Q3 might be your 75th percentile. So I think you could probably find Q1 in the same manner. And if you found the ages for Q3 and Q1, you could probably find the age range for your IQR. It's a little hint for you. All right, so pause the video, work this out with a partner, someone around you, and then come back. All right, so this is fairly simple. I didn't draw it out though. Here I'm going to guesstimate. There is about my 75th percentile, so it's right about, God, it's atrocious, about there at 48. My 25th percentile would be about here, and so that's pretty darn close to 20. And so then I want Q3 minus Q1, 48 minus 20, which is 28 years. Put some units on there. And then they say, what is the percentile for the shopper who spent $19.50? That's going to be pretty close, actually, to what we have here. So since I got 20 for 25%, I'm just going to make it a little bit below, and I got 24%. But these are all approximate. It's never going to be perfect when you're reading a graph like that. All right, so once again, I'm not going to bore you with how to find z-scores. I probably just bored you with calculating percentiles. But those ogive graphs are a pretty cool way, and AP likes those kind of questions. So let's talk about standard scores. Where am I? Yeah, here I am. Okay, so y'all calculated z-scores last class on your little unit, on your little activity, and on the very first page I gave you the formula. It's just the value that you're looking for, so they want to calculate a standardized score for 93 minus your mean divided by your standard deviation. And what this tells you is this tells you the number of standard deviations away from the mean. And if you're ever asked to interpret a z-score, this is what you would say, of course, with context of standard. This is how to abbreviate standard deviation away from the mean. So it's also kind of a measure of position in terms of the mean and standard deviation of your data set. You could also hear they found for 72. 72 is the value you're given, that's x. 80 is your mean. SX is your standard deviation. Okay, so here are one of the things we like to do is we like to compare data using z-scores. So how we can do this is we can just take, especially sometimes you'll look at like two different years of sports data. So you want to compare Babe Ruth and Barry Bonds. I think that may actually be a homework question. And you could do that, but you wouldn't want to compare Babe Ruth to the people who played baseball in whatever year Barry Bonds played baseball. I'm horrible at sports. Nor would you want to do it vice versa. So you could compare them using their z-scores, find the mean and standard deviation for whatever it would be, batting average for the year, and then you could compare them that way and see who has really had a better batting average. You could compare your SAT and ACT scores. You think you did better on the SAT? Well, you could compare it to the ACT using mean and standard deviation and calculate z-scores for both. Whichever z-score is higher, you did better. Whichever z-score is lower, you did worse. All right, so the higher the z-score, the better. And there's a few cases where a higher z-score would actually be worse. We'll talk about those. You did compared to the group. Well, if I could spell, that'd be awesome. Getting ahead of myself. So just think about where high scores are bad, and that would be where the higher the z-score, the better would be. The worse would be, sorry. I did that backwards. So here's an example for better. If you would want to do better on a test, so test scores. Here's an example where a higher z-score would be worse. That would be like a golf score or a bowling score. Right? You know, golf scores higher is worse than lower. So you do have to kind of read into the context of the question and make sure that you're understanding whether a high z-score is better or whether a high z-score is worse. So here we have another practice problem. This shouldn't take y'all but just a minute. So pause the video, work this out, and then we'll look at the solutions. Did I show you the solution for the other one? I did. It was super short. Okay, never mind. So pause the video, and we'll look at the solution for this one. All right, so here are the mean, standard deviation, and x value for SAT and ACT. So we have our student score. Eleanor scored a 680 on the SAT, so that's my x that goes into the formula. And then here's mean and standard deviation. The ACT, here is the score Eleanor made. She made a 27. Mean and standard deviation of ACT is 18 and 6, respectively. Those are a little outdated. I think it's a little higher. I think it's around like 20 point something now. So I calculated the two z-scores, x minus x bar over sx. Same thing here, x minus x bar over sx. So since she had a higher z-score on her SAT, she did better compared to the other test takers. Pretty self-explanatory. Okay, so let's go back to transforming data. Oh, not quite there. Okay, so transforming data, what we're going to do is we're going to look at the effect. I think that's effect with an A. I'm awful at that though. Of adding, subtracting, or multiplying all values in a data set by some number. And what we're going to be looking at the effect on is we're going to see how does it change what we call measures of center. And measures of center are mean, median, center and location. Are mean, median, quartiles, and percentiles. I really don't want to write that twice, so I would underline that. You are going to need to know what a measure of center and location is. Center, I'll write it down for the left just so I know that you know, is mean and median. And then position is quartiles and percentiles. All right, and then we also will find out how it's going to change measures of spread, or the shape, actually. And measures of spread are range, IQR, and standard deviation. I'm not going to repeat that. Those all make sense. Okay, so we're going to talk about first what happens when you're adding or subtracting a constant. So say I have a group of test scores, and I've decided that I'd like to give everyone a 5-point curve. That would be adding a constant to all the data values. And I want to see how will this affect my mean and my median, my quartiles, my percentiles, range, IQR, standard deviation. So I'm going to erase all this mess that I just wrote and see what this actually says. So this says if I add or subtract a value from every data value that I have, it's going to add or subtract a. I'm going to get my highlighter here. It's going to add or subtract a to all the measures of center and location. So this, if you see, look at this graph down here. This is exactly what's going to happen. So we have taken all the data and we just increased it by 5 or whatever amount you've increased it by. And it just shifts the entire distribution up or down that amount. So the mean and the median will change as well as all the other measures of position and location. Okay, now what doesn't change is the spread. If you'll notice here, this right here, the spread of this data set is the same because all you've done is shift it. It isn't any more spread out. You also have not changed the shape of the distribution. The shape is still exactly the same. So you will need to remember this. I might put a big X by it. I might write it on a piece of paper in your notes. I might write it on the top of your homework. If you're adding or subtracting, measures of center and location change, but measures of spread do not. All right, so now let's go to multiplying. Okay, when you multiply, everything changes. And here's a picture down here. Divide also does the same thing. Here we've taken a set of data and we have multiplied everything in the data set by a constant. And notice that my data is now much more spread out than it was before. So all of my measures of spread are also going to change. Notice that I think about here would be my center, and now about here is my center. So the measure of center and position also have changed. So if we go back up here, multiply or divides the measure of center and location by B, which is B is whatever you multiplied everything else by. And it also you're going to multiply or divide the spread by it. So there's no fancy math here. It's all direct. If you multiply every value by, say you increase everything by 10%, then all you're going to do is you're going to increase the mean by 10%, standard deviation, all of it. So no fancy math there. Just multiply or divide by whatever it is that you're multiplying and dividing everything else by. The AP loves these questions. We're actually going to revisit this topic a little bit later when we talk about something else, but they really like these types of questions. They want you to realize what happens when you add a number to every value, when you multiply every value by a number, and so on. So here's an example. I don't want to read through all this. I just like the pictures. You are more than welcome to read through it, though. It would probably help you out a lot. Here's something interesting. Here, what they have is they have a cabin, and they want this cabin to stay below freezing. And Mrs. Starnes sets the thermostat at 50 degrees, and she wants to check and see. Okay, so she buys a digital thermometer. Okay, here she measured it, the temperature, but it's in Celsius. So she wants to take all this data and convert it to Fahrenheit, and then see how the mean and the median and everything else is going to change. Okay, so here is our data right here. We're given the mean. The mean is 8.43. The first question says find the mean temperature in degrees Fahrenheit. So you've got to think what happens whenever you are converting to degrees Fahrenheit. You're multiplying and you're also adding. So you've got to think of the rule for multiplication as well as the rule for adding. So for mean, which is a measure of center, if you add, you add. If you multiply, you multiply. So what all you're gonna do is you're gonna take and plug the mean into this equation and then calculate it out. That's what they've done right here. And 47.17 is your new mean. So the next part B wants you to calculate the new standard deviation. So we have to think about what the rule says for measures of spread. So for measures of spread, when you add, nothing changes. But when you multiply, you multiply. So what's going to happen is, all we're going to do is we're going to take the standard deviation and we're going to multiply it by 9/5, but we're not going to add the 32 because shifting it up doesn't change the spread. So that adding 32 isn't going to affect the standard deviation. So if we look at this example down here, they say multiplying each observation by 9/5 multiplies the standard deviation. Adding 32 doesn't affect the spread. So all we want to do, if we want to find the new standard deviation, we take the standard deviation we're given, 2.27, and we multiply by 9/5, and we get 4.09. I guess y'all can read just like I can. All right, and the last question is for percentile. So here we have percentile. They say the 90th percentile of the temperature readings is 11 degrees Celsius. What is the 90th percentile temperature in Fahrenheit? So percentile is a measure of position, right? Location, I think it all means the same thing. Position or location. And so here, if we look back at those two sets of rules, when you add, you add. When you multiply, you multiply. So we're both going to add and multiply. So we are going to take our 11 degrees Celsius, plug it into the formula, and we get 51.8 degrees Fahrenheit because we multiply by 9/5 and we add 32. So really you just have to think in your head, okay, am I adding, subtracting, multiplying, or dividing? And once you figure that out, you say, okay, is it a measure of center, position, or spread? If it's a measure of center or position, you're just going to do whatever it is you're doing, the whole gamut. If it's a measure of spread, you're not going to add or subtract, but you do multiply and divide. All right, so here is an example. So y'all get together, work out this example, and then come back and I'll give you the solution. All right, so here we have, they say that they had the heights of all the students in Miss Walker's class, and then they had them stand on a chair which is 18 inches off the ground. So what they've done is they've added 18 inches to their height. So it's going to be the height plus 18. Now we want to know what are the mean and median. So I know that mean and median are measures of position, right? So if I go back and look at those two sets of rules that I told you you had to remember, then I know that both the mean and the median are going to change because when I add, measures of position change. So I take my mean, which is right here, and I add 18 to it. I get my answer. I take my median, which is right here, and I add 18 to it and get my answer. Easy enough. All right, so then it says find the standard deviation and the IQR of the measurements. I think Miss Amelia's ready to go home, and so am I. Okay, so here is the standard deviation. Okay, so sorry, I got distracted. We think, okay, so standard deviation and IQR are both measures of spread. Now, when I add or subtract, my measures of spread will not change. Remember, if you think back to those rules. So my standard deviation is the same, right? 3.2 and 3.2. They didn't give me IQR, so I went ahead and calculated it. Q3 minus Q1. But they're just the exact same values that I got from the chart. All right, so that's all I've got for you today. So I want you to read these examples since I didn't go through all of them. Since you do have eyes, I know you all can read. And work the homework, and then I will see y'all next class, and we will talk about the normal distribution.